this call is important for us to be able to communicate with the industry at large, the Advanced Photonics Coalition charter and drive, and the things that we have set out for ourselves, the things that we're doing, and the things that we're going to do. So, without further ado, I'd like to introduce Jeff Maki, who is our Advanced Photonics Coalition president and chairman of the board. He's also at Hewlett Packard Enterprise. I don't know your new title, Jeff. He was previously at Juniper Networks. And so, Jeff, the floor is yours.
All right. So yeah, at HP, I'm a senior distinguished technologist. So I wanted to tell you today about the value proposition APC is presenting to the industry is that we're doing photonics ecosystem driven standards. So we're delving deep into the implementation in a sense, different from other standards groups that want to define high level specifications and not touch the actual hardware and its nature so much. So um, we're really the supply chain ecosystem driven standards. So across the top of this slide, we're highlighting some of the key aspects of this ecosystem. We have a language of talking from the top down or from the bottom up of the ecosystem. But our goal then is to create the best scalable manufacturing practices, identify and remove differentiation in manufacturing practices that hinder scalability. Doing things different for no good reason doesn't really help drive high volume. So each level of this ecosystem provides both requirements down the ecosystem and technical input up the ecosystem for formation of standards. So there are people that are technologists, they know how to do things, but they don't know what the industry exactly needs. And that's where we get the requirements from higher up in the ecosystem. So we want to lower the barrier to entry of new technologies. It's difficult for a new technologies to enter the market if it's sole sourced. So we are enabling the multi-sourcing. And then photonics promises to solve the challenges of the increasing AI infrastructure needs. So I think we've all recently seen a lot of discussion about scale up networking truly going optical. And there's a roadmap now for that for many companies. One of the things at APC is we know we're not doing standards alone. There are many other orgs, and we need to do it all in a cooperative, synergistic manner. So we each have a role to play. So I started creating this table some time ago, and we've been adding to it. And so we're identifying like the IEEE 802.3 is at in a sense, at the top of the ecosystem of standards defining uh, Ethernet itself and interoperability. And then there's the OIF, which is very involved often with electrical specifications and starting the industry discussion on the next higher speed. And then a lot of that will then lead to activities, new projects in 802.3. And so then there's the MSAs that step in to fill in some gaps in a very timely manner. And so we may have seen an OFC announcement of like 5 new MSA groups. So quite a bit going on. Those can be anything from form factors to signaling standards. And then there's APC in the middle that we're discussing today. And then we are wanting to do everything very cooperatively with OCP because we know that OCP is really looking at the high level system aspects, air cooling, liquid cooling, immersion cooling. They've been working on a lot of different schemes in the power supply and chassis design. So, and then there's other organizations that are helping out with relating to fiber and so on. So we're 50 members strong and have more now. And then uh, Advanced Photonics Coalition, again, looking at the supply chain, look as like a constellation here. We can then map all of our member companies to each of these areas of the ecosystem. It's not that we're trying to peg hole them, but we're trying to show that we have good coverage across the ecosystem. I'm not going to take the time to read them all out to you, but the idea is that we have good coverage here. And then what are we doing in APC? So right now we have 3 working groups. We have the silicon photonics, looking at low-cost manufacturing at scale. We have multi-core fiber, rack density management, and then co-packaged optics, solving challenges for adoption. So, and then within each of these working groups, there will be additional ad hoc groups or focus groups formed to address specific design considerations for each parent working group. So we're working towards a portfolio of specifications. That's what we're in business to do, is write specifications. But then also provide several CPO reference designs and some design guides, buyer's guides, and global industry roadmaps is what we further aspire to do. So this is our current leadership team. The slide needs a bit of an update. But point is we have our broad coverage of people very involved, and now we want to hear from some of them today about the various activities in APC with more of a deep dive into the actual specification work. So thank you, and please join us. So I'll stop sharing and let us move on to the next presenter.
Thank you, Jeff. So let's see. Our next presenter is going to be Vikas Gupta from GlobalFoundries. Vikas is on the board of directors here at Advanced Photonics Coalition. He was one of our very early members and has been helping us define the charter here at APC for a couple years now. And so, Vikas, I'd like to have you join us, please.
Yeah, okay. So thank you. Let me just set this up. Slideshow, primary monitor. Okay. And put this in slideshow mode. So what I wanted to talk today is about just standardization and the work, the APC is doing, and why standardization is so critical. And I wanted to just start with, sort of a readout of OFC. OFC, as Jeff already mentioned, I would say the theme of the OFC this year was primarily the number of MSAs that were released. There was one on, the signaling protocol for OCI. There were two form factor based MSAs, the XPO and the open CPO standard. So clearly, even the industry is starting to realize we can't have the wild, wild west in order to get the scale of deployment that is needed. And so towards that, I wanted to just use maybe 5 minutes to explain the criticality of why MSAs or the standardization effort is so important. So I wanted to just show you, start off with, there are different form factors as we talk about co-packaged optics. There are different form factors that have come into play. On the top, I'm just showing you the PIC face down with the fiber attached unit, through a cutout, or the face down PIC. This is sort of the more typical CPO implementation with the ASIC and the PIC sitting on a substrate. Next is sort of an interposer-based solution. And then of course you can start looking at electro-optical interposers. All of these form factors are being explored by various vendors and hyperscalers, and you will see this proliferation of form factors. But it's important as we start industrializing these efforts that there is some amount of standardization. And so towards that, I would say, let's start with the fiber attached unit and, this whole need for detachability. GlobalFoundries had pioneered this effort on the V groove based. These are permanently attached fibers, and it's a direct coupling method into the spot size converter. But as you start talking about detachable fibers, it's important to be able to so increase the mode field diameter in order to get the tolerance required for the mechanical coupling of these detachable solutions. And I think the reason this becomes important is just using an example of the OCI MSA. The OCI MSA requires 4 lambdas in each direction, so one for transmit, one for receive. And you can see, GlobalFoundries has pioneered these detachable solutions, which are broadband, and you can see the loss over the whole CWDM band being relatively flat and low loss. And you can see as part of that, it is important as part of these standards to be able to transmit all of the wavelengths versus some of the grating coupler solutions that are available in the industry. So this is an example of how MSAs impact solutions, and it is important for the technology solutions to align with these standardized MSAs. And this sort of detachable solution or this MSA then has also bearing on test, because now you have identified wavelengths, you have identified coupling solutions, which allows for this proliferation or industrialization of test also. So what I wanted to do again, I'm going to stop here, but just give some aspect or some appreciation of why standardization or the work that APC is pioneering is important. Okay, thank you all. I'm going to hand it back to Melissa.
Thank you, Vikas. I appreciate that. And that GF Photonics platform is a very, very important and required part to all of us getting to CPO. So next up, as we have Kees Propstra from Quantifi Photonics. Quantifi was also recently acquired, just like Juniper Networks, by Teradyne company. And so Kees is running our test and measurement focus group underneath the Silicon Photonics Manufacturing Parent Working Group, and he is also a board of director here at Advanced Photonics Coalition. So, Kees?
All right, good morning. Thank you very much, Melissa, for the introduction. So let me share my slides. Let's see, can you guys see my slides in presentation mode?
Yes, we can.
Excellent, all right, perfect. So we are part of the Silicon Photonics Manufacturing Group. So we're the test working group. So I wanted to express my thanks to Rafael from EXO and Lawrence from MPI Corporation for their contributions as well. So what is our mandate? So obviously, we are now starting to build all these devices based on silicon photonics. So we really need to standardize the testing for these photonic IC manufacturing process. The focus is really on high volume manufacturing, looking at test time, throughput, and cost of test. So in this working group, we're going to define the test insertions as well as the test programs. What are the tests that you're going to run at specific test points? And then we'll focus on the parametric testing, where we define a minimum set of parametric tests that should be sufficient to be able to produce these quality products in high volumes. In addition, we want to talk a little bit about how to extract the true device performance, making sure that if you do a measurement, that's a good correlation to the actual behavior of your device. So the core mandate is really, how to efficiently test products that are produced in high volumes and are spec compliant in the end user application. Obviously, that's a key element to that. So we all know about the industry trends, of course. Vikas already mentioned OFC, where there's a lot of new standards being introduced. But the idea is really that we're building, high density devices, lots of channels, multiple wavelengths. We have photonic ICs. We combine it with electrical ICs. We have sometimes external or internal laser sources. It's based on photonic IC technology, and it has lots of high-speed interfaces. So we know how to produce wafer-based technologies in high volumes, but doing that, in optics, of course, is quite different. So first of all, you need to test optical parameters, and then, of course, you have the probing, how to connect the fibers, the fiber array to your device, and then, very importantly, you really want to test these devices before you put them in the field. You really want to test every channel at speed to make sure that they're going to perform, as according to spec. That requires a lot of high-speed, 100% testing. Obviously, which could become a bottleneck if you don't, plan that ahead. So the typical test insertions that we see, of course, is you start with the wafer, just the photonic IC. Then you have the photonic IC with maybe an IC. On top of it, still a wafer level test, the typical double-sided probing that we see for let's say coupe or comparable wafers. Then the next step is you dice it in multiple die, or you have multiple die stacked together as a singulated die product that needs to be validated. And then, of course, you start combining it with interposers, PCBs, maybe fiber arrays or detachable fiber arrays. Then you put it into a module, optical engine level. And then the next step is actually plugging it into either a switch or having a complete CPO switch assembled together that also needs to be tested. So these are the typical test insertions that we see. Then if you look at the test regimen, and forgive me for the small details, but obviously otherwise it wouldn't fit. But again, you have the multiple test insertions. Then you have the different test categories from passive testing, just basic insertion loss, return loss, or active testing. You power a device, you control a device, and then you look at the response. And then high-speed testing, either S parameters, I diagrams, or bit error rate testing. And what you see here is that we talked about this shift left. You really need to test a lot of this kind of early in the process just to make sure that everything is going to work, so that you don't start building a device from a chip, an IC that is not going to work. So we test a little bit more on the left, and then for the intermediate steps, you test a little bit just to make sure that you haven't damaged the part, that you haven't impacted the bandwidth too much. And then at the later stages, like module level test, you need to do kind of a full characterization. Is it meeting all of the specifications over all the conditions? And then system level test is more like an interoperability test. So you kind of wave yourself through this, these test insertions with the test plan to make sure that you do it efficiently, but also that you have, that you know for sure that your product is meeting the specification. So if you look at the test philosophy behind it, so you do the shift left, test early in the process to weed out potential failures, making sure that you only start working on parts that are meeting specifications. Then a sanity check for the intermediate stages, make sure that the step has not impacted performance, hasn't damaged anything, and then a pretty serious pass fail final test prior to deployment. And then really what is really important is to streamline the test protocol. We call it kind of the test funnel. It's another shift left. Test a little bit more in the development phase so that you can really reduce the test coverage in high volume manufacturing. That's really important to be able to go to these high volumes cost effectively. So Expo provided some guidance on how to do these measurements very accurately. I don't want to talk about the details here, but we specified it in our proposal. It's very important because if you do characterization, of course you have fiber arrays or you have probing involved. You really want to make sure that you characterize your DUT and not your test system. And then based on some feedback from MPI, of course there's a lot more testing that needs to be done, but we started to focus on this. This is really starting to drive the volumes. But obviously, environmental testing, very important. Reliability is a key concern, of course, in AI networks, so it needs to be planned properly. Burn-in testing. And then, of course, you have a lot of additional parts that make up the complete system that need to be properly tested as well. So this is kind of the overview of the platform, the framework for testing, and we're now starting to build on this to add details to really, come up with a consensus view on how to test these devices in high volumes. All right, that was my presentation. Thank you.
Thank you, Kees. We all know that reliability is a really big factor here, and so that is a very important overview. Thank you. So next up, we have Bryan Hall. Bryan is our co-packaged optics working group chairperson, and he's also the VP of Sales and Marketing at Colorchip. Bryan?
Welcome, morning, evening, afternoon, wherever time zone you're in. I'm going to follow on, of course, everyone that was in front of me. But I think it's important to differentiate what we do here, as Jeff mentioned and several times, is we're focusing on a system level specification. And that's why we looked at silicon photonics with Vikas. We looked at test and measurement with Kees. But I'm going to take it up a level with CPO, and I think I have time here, so I'm going to try not to rush through this. So why are we here today? And before OFC, I would have said, hey, I need to convince a few people that CPO is real and you got to get interested. But after sitting through the executive session and then 3 days of other sessions and then the event, um, I don't think there's any need to convince anyone that CPO is coming. It's coming quickly, and it's one of a few viable solutions for data center scale up, scale out, and who knows, maybe scale across at some point in time. But right now, I'm looking at it as far as my standards group as a scale up solution, and with optical scale up, it even makes more sense. So obviously, AI fabrics are pushing switch ASICs to 102 gig terabits and beyond. Power and faceplate densities becoming binding, and I think that was one of the reasons you saw the XPO MSA introduced, which is another alternative or another solution. There's never a single technology solution in this business, so I view I view what we're doing with CPO as complementary to several of the other standards that were proposed. Pluggables cannot scale efficiently beyond 224 gig. Um, we will see how that goes. I mean, there's always the power and thermal issues. There were some early demos at the show at 400 gig plus. We'll just have to see how that plays out. And it's not a technology transition; it's an ecosystem transition, and I'll get into that in a little bit. So realize, from our view, CPO must be deployable, interoperable, and scalable, and not proprietary. And at some shape, form today, every CPO offering is proprietary, whether it be within in-house or proprietary engines without the ecosystem built around it. So what are the operator challenges? And when I say operator, talking about the hyperscalers, the tier twos, the neoclouds, whoever it may be. Exploding traffic, increasing optical I/O per ASIC, and power per bit now a dominant constraint. If there's another message I walked away from OFC is not only is CPO mainstream and growing quickly as far as realizing it's a viable solution within the data center for growth beyond 200 into 400 gig and beyond 400 gig per lane. But it is focused on power reduction because there's a number of considerations when you look at new data center development. Of course, it's power, water, and real estate. After OFC, it's power, 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 and all the rest of them can likely be solved if you fix that. So operational realities, predictable failure domains, field service models, and long-term supply chain. And without standards, CPO becomes a high risk for deployment. In fact, if you remember, maybe only 6, 8 months ago, there were some folks in the industry who believed that the failure domains around CPO were too significant to consider it. And I think those concerns have now been alleviated with a lot of the work we've done in other companies. What changes with CPO architecturally? Optical engines co-located with the switch ASIC, short electrical reach, long optical reach. And when short electrical reach, I mean that the purpose of CPO is to put your optical engine right up against the die housing the ASIC. So as much as possible, eliminate any electrical connectivity for power and heat. I mean, thermal issues are very significant. And fiber aggregation moves off the faceplate and onto the ASIC, the die, and many different methods of coupling, whether it be beachfront or 3D. Benefits: lower electrical loss, improved bandwidth, and of course, potential power level savings. Let me get to the right slide. So what are some of the new challenges with CPO? And there are challenges. I'd like to tell you today we have all the technical issues solved. We have all the ecosystem solved. And the reality is we do not. And that's why we have mid-50s as far as members in our group. We're all working hard. There's a lot of new technology, a lot of interworking, a lot of system level issues that we're working through, including the ones that you can see here, and but not limited to the ones you see here. So CPO is not just a component swap. It's not taking a 200 gig per lane pluggable off your faceplate and then running in a 400 gig per lane into your faceplate in the next year or two. It's a complete change in the system design, operation, and testing. And we've covered a little bit of that prior to me today. So for operators, Avoid vendor lock-in, and that's another very significant driver with CPO and other standards-based solutions is operators want to have a choice. They don't want to be locked in. Of course, they like lower pricing. So once you get to a standardized solution or a standardized specification, companies can do what they like with it and compete how they like. For suppliers, stable integration, reduced customization, and a much larger market to sell into, which drives economies of scale. So far, so good from the operators, the supplier, and for test and measurement, well, I think Kees covered it pretty adequately, better than I can ever do. So we'll move on. What are we standardizing? Mechanical envelope, electrical channel definitions and compliance points, fiber attached and external connectivity, management and telemetry, reliability definitions and failure isolation, compliance and testing, interoperability, and test and measurement. If we can't test it, we can't measure it, we can't monitor and surveil it, it really doesn't do us much good. So we are not standardizing internal proprietary engine designs. In fact, we are open to all companies that like to join and would like to contribute. And we will have multiple engines driving our CPO specification. Deployment and test considerations. I'll just say this because I think I'm getting close to my timeout. Standards reduce the risk across the entire life cycle. But CPO will only grow if we scale to operators' desires and expectations. Suppliers can build to a stable target. Test companies can validate interoperability, and the ecosystem commits to openness. So CPO only succeeds if we standardize the ecosystem, not just the interface. I think if you were in the executive session, or even if you weren't on Monday at OC, it was very interesting to me that Meta, and everyone here probably knows Meta's been doing some long-term testing on CPO systems in their lab, and they have, from what I've read, over 10 million hours of CPO reliability. And the comment from the Meta expert was, it's at least 2 times as reliable as transceiver-based faceplate solutions. And they said it would have been 10 times as reliable if a known defect in the ELSFPs, which are the front laser interface on the front panel for a CPO chassis. But without that known fault, it would have been 10 times more reliable. So where are we as far as our group? This is for public consumption. We have a lot more detail behind it, but unless you're a member of the group, we don't share a lot of the detail. So please join. If you look at the stacked architectural solution today, and you can see we have everything from motherboards to PCBs to substrate interposers, and then the components on top. And whether the components sit on top of a silicon or a glass substrate or another layer, it's all part of our proposed architectural reference design. And of course, over here you have the external lasers, which I mentioned earlier, which are your ELSFPs, external laser, small form factor pluggable. And my last slide is just to demonstrate an add-on what I think Jeff presented earlier. He provided the constellation of everybody surrounding APC. I just wanted to show you that within each of these layers, we have multiple companies, multiple inputs. No one's going to design it around only their system. And therefore, we will have a true open-sourced CPO specification and reference design for all people that would like to join and participate. So hopefully you join. Be better if you join and participate. Thank you.
Thank you, Bryan. And as Bryan mentioned, we really don't share any information outside of this organization. We are all in a confidentiality understanding where we share information amongst ourselves and we share information within our companies, but we don't share information outside of our companies or outside of this organization. So that's why it's important to join, as Bryan said. Okay, next up we have Julie Adams. She is our Vice President of the Board of Directors. She is also a Business Development Executive at IBM. Julie, are you ready? Oh, and
Yes.
Julie
Hi,
is,
everyone.
sorry, Julie, she's the chairperson of our Silicon Photonics Manufacturing Working Group.
Yep, a few titles. So thank you, Melissa. All right, let's see if I can share my screen here.
Okay, we see it coming up.
All right, I'm going to put it in presentation mode. Okay, so can everyone hear me?
Yes, we
All
can.
right. Okay, great. So just wanted to go through, I know Bryan and Kees and Jeff have covered quite a bit, and same with Vikas. This is more just talking about where we're seeing things happening, what we're providing to the industry and why we're involved. In general, with IBM and our data centers and other things that we're expanding, the whole market is starting to explode with large language models and generative AI demands, which are unprecedented. The bandwidth required, the low latency, and the energy efficiency is in a necessity. That's why we've all been talking about this. The hyperscaler AI factories, millions of GPUs require, high performance interconnects for training and inference. And then the drivers, as Bryan mentioned, really massive data transfer needs, the energy efficiency, the scalability for the AI clusters, and the industry investment in making this happen. And we heard Meta talk about some of the data centers are going to be the size of Manhattan. If you talk to SpaceX, they're going to put a data center in space. So we're running out of land, I guess. So you might as well go up into space. The scale out networks, the CPO enables long distance, high bandwidth links. So it's rack to rack, the lower latency and power for the cloud fabrics, Ethernet and InfiniBand. And then the pluggables remain the compute nodes for flexibility until CPO matures. As everyone's hearing, and those that participated in OFC, there were a lot of talk of CPO, but the scaling is not happening as quickly due to some resistance and implementation. But we are seeing that happening as quickly as possible as the supply chain and the open references start to happen and people get more comfortable with it. As well as the scale-up networks, CPO is going to replace the copper for GPU to GPU and the nodes to switch fabrics. So the greater connectivity, longer reach, and lower power, and the initial deployments start to scale before expanding to scale out. So there's a lot of messages here that are the reasons why. You've heard that from the other folks that spoke before me. But in general, IBM is has a manufacturing corridor on the East Coast. We are implementing tremendous amount of technology going from the lab to fab out of our Yorktown facility. We have our Albany Research Center, which is expanding technology. You need the implementation for heterogeneous integration with CPO in many aspects. We have to have die stacking and other types of high-level integration in order to enable CPO. And then we have our manufacturing site, which is in Bromont, Canada, which has been in supporting business since the early 70s and has opened up the market to be able to support advanced packaging and CPO. And then some of the offerings of CPO that you might see out in the industry with the co-packaged copper, we still see a tremendous amount of need for connecting the short reach, high speed electrical links and the switch to switch connections. And it's providing bandwidth of 112 to 224 gigabits. But then to go to the next step, as Vikas mentioned about fiber attach and vGroove, having that ability to direct couple with a spot size converter that provides a bandwidth of 400 plus gigabits per second. And then taking that even further, being able to expand a higher density with a polymer waveguide, providing the much more dense beachfront opportunity. And the target reach for obviously the CPO is getting to 2 meters and beyond. So, and then where we see the needs and why we're involved is really the mechanical coupling and interface. We have a focus group that's looking at the light coupling strategies on a photonics integrated PIC dies, the key parameters and dimensions for each of the configurations on the PIC die, and then the optical components and integrated connectors and associated parameters. We're also looking at the cleanliness and contamination levels, because if there's any type of contamination on the fibers or on the PIC die itself that you're making the interconnect, it is not going to provide the right performance, or it might be, a failure. And then the refillability of optical interconnect. And then looking at the test measurements, as Kees mentioned, trying to look for clear insertion losses and calibration for reference, the connection, repeatability evaluation methods, and the test methods at a module level with CPO being oriented, and then the high power laser standardization. And then also looking at the architectures, the beachfront density, the fan out length, the fiber attached unit length for the rack compatibility, and so forth. So there's a lot of things that are happening within each of the groups within APC to help drive the need that we're seeing, and the fact that we had a lot of high mix, low to medium volume that isn't going to scale to high manufacturing unless we all come together and start working in these open source opportunities that will allow the industry to be able to scale to high volume. And at that, I will go ahead and hand it over back to Melissa.
Thank you, Julie. All right. Next up, we have Dominik Rabus, and Dominik is the co-packaged optics system architecture focus group chairperson, and he'll be also covering the multi-core fiber working group charter. Francois Beauregard of Belden is the chairperson of the multi-core fiber working group, but he could not be here today. So we have Dominik covering both areas. Welcome, Dominik. Dominik is also a key technologist at Alcyon Photonics.
Thank you very much. And as I am the last person here presenting, I'm very happy to provide you a summary of what we are doing here in our system architecture focus group. So I could simply say everything what you have heard before. We are putting together and integrating it. And as also Jeff was mentioning, this is going to be put into a standard. But before going into those details, I'll give you a short intro into the focus groups, because we have those 3 working groups, as also the previous speakers have said, and we have 6 focus groups. So we have got our system level architecture group, we have got the system management interface focus group, design and simulation, which is also very important for us here, because we also want, and we have coined the terminology design to test, which is very important when you are, as everybody was mentioning before, we want to test and validate that in order to get really the reliability and the robustness of the systems. We've got the silicon photonics interface group, we've got the high density optical interfaces for CPO, and of course the test and measurement. And now give you a short glimpse into what we are doing in our focus group system architecture. We've got a very talented designer, and what you see here is we want to really cover basically all relevant interfaces. And in order to make it understandable, what we are doing is also providing insights and using educational tools to help ourselves as well to understand where all the member companies are coming from and how to provide those relevant interfaces. And as Melissa just mentioned, we're not focusing only on the single mode, single core topics, but also you can see here single mode 4-core multi-core fiber. And how do we work on this? Because at the moment there is no standard existing to do that. And also we are looking ahead into this topic. And that's what we are covering in the multi-core fiber working group. How does the fiber attach unit look like? How do we cover it? And how does that all interface into what Julie, for example, was showing in the CPO? So also the optical fiber coupling is an important topic here, and therefore we've got also a lot of member companies dealing with this topic. Then you've seen this slide already before with all the member companies here. And maybe as I've seen one comment in the chat from Dan regarding because of ELSFP, of course, we've got the external laser, but we also are taking care of integrated lasers or integrated light sources. So that might answer your question. So of course, as we are an open ecosystem and we should be agnostic in this regard. So we would call it a different flavor of a CPO reference design. And so we have to take care of this interoperability. And of course, as we have to put some priorities, the first task is the ELSFP, but that does not mean that we are not forgetting that or don't have it on our radar, especially in the system architecture focus group. So we've got our priorities, but then of course, depending on what is available in regards to high volume manufacturing. So also the topic on integrated lasers, and you see here we've got also some member companies here present, which have got expertise in this domain as well. Yes, I have the updated slide. You see the plus here. So we are 50 plus members. We are very happy of this. And please join. As you see, the momentum is there. And I conclude with one slide. You see here a chassis. We are ready. There is some more space here. So we want to put your logo in your company here. And we need some more devices to be filled here. And I'm happy to do that in our system architecture focus group. And with this, I think it's open for questions. Thank you.
2023 is when we launched Advanced Photonics Coalition at our Photonic Cloud Computing Summit that we have with Optica. And we'd love to see all of you there. That is in October of this year. It's called the Photonic Enabled Cloud Computing Summit, or PECC Summit. And so it's been less than 2.5 years, and we have now about 55 members. And all that shows is that the industry really needs a place to come together, to work together, to collaborate, to move this industry forward to high volume manufacturing at low cost, and that is our primary goal. I think that the momentum speaks for itself. I really don't have much more to say other than this success goes to each and every one of you that are on this call or that has contributed to this organization. It's important for this standards organizations to come together, and we have. So without further ado, I think we can go into some comments, and I think I saw one in the chat. So this one comes from Dan Pitts.
You know, when you standardize things, you have to make sure you're not standardizing the wrong things too early, or you stifle innovation. And there's a lot of innovation going on in this ecosystem right now, and a lot of experimentation and new solutions. They will not all win, but the marketplace is going to have to decide. I like the emphasis on physical things that really should not differentiate the sort of the system aspects of these different proposed solutions. So I think it's going to be important for this group at APC to standardize the right things and only the right things.
Fully agree with you, Dan, here. And therefore, as I said, we are not letting out any technology in this regard, but we are going, let's say, in parallel, if we may say that. Of course, some horses are faster than the others regarding maturity level, but I think we are, as Melissa said, more than 50 members, and all of them is like swarm intelligence, I have to say. And we've got some big players on board which keep us updated on this topic.
Well, it's important to have the different categories of members, you know, the vendors, the deployers, the users, and the integrators, and the manufacturers.
Agree. Thank you.
Thank you. Absolutely.
Yeah, just one point, Dan, that I made at our OFC APC presentation is there's a lot of vendors involved with APC, especially around CPO. But every one of those vendors talks to a lot of customers every day, every week. And although we have some name brand end users like Microsoft who have now joined, I would venture to say that most folks on our team, if they're like me, have 10 to 20 to 30 customer conversations every week regarding input, where they want to go, and all the things about that. So there's a lot of end user input, and from the hyperscalers all the way down to tier 2 and 3 cloud operators. You also asked another question, like it said CPO is inevitable but not imminent. Well, whatever time frame someone thought that meant is fine. My own view is I think CPO and pluggables will share the data center space at 400 gig per lane. Then whether you think that's next year or early the year after, I don't know. That's my view of where our reference architecture, our ecosystem, and our solution and value add to the industry will be.
Thank you, Bryan.
I'll just make one comment about, the CPO. I think we should, be cognizant of deployment of CPO, and we may say deployment of CPO is a couple years away. But remember, these things don't magically appear on the date of deployment. And there's a long gestational period in terms of development to make sure that the ecosystem exists and the technical solution is solved. And so even if we talk about deployment in a couple years, the technical solutions need to be solved today. The standardization needs to occur today. Test solutions need to be available today for this sort of scale deployment to occur even a couple years from now. So I think we should separate out, deployment date. We say, okay, deployment is, a couple years from now. Why are we talking about it today? We're talking about it today because all of those challenges need to be solved today for that high scale, high volume deployment to occur in a couple years. Otherwise, it's not going to occur.
That's a really good point, Vikas. I'm not sure if I speak for anyone else, but I looked to GlobalFoundries to help us define what known good die actually means.
Right. Yeah, I mean, this goes back to some of the comments that some of our test leads have made. It's sort of a supply chain, right? Once you identify the signaling protocol that allows you to, talk about packaging, which is intimately then linked to test and testability. And so it's all a continuum of, the standardization leads to a lot of the standardization of this downstream ecosystem, which allows for standard test protocols, which allows for known good die, known good modules. And so it's all a continuum, and we're all sort of holding hands in a human chain or ecosystem chain, and we all benefit from efforts that the APC in some cases is leading.
Thank you, Vikas. So Vikas said that we're going to be deploying in a couple of years. Well, how do we really do that? Well, it has to do with an open ecosystem. So here we do write specifications. We will publish a portfolio of specifications, but we will also present several different reference designs based on, as we mentioned here, customer requirements or vendor requirements. And so the reference designs, the specifications, going to have a design guide, a buyer's guide. All of our vendors' success is APC success. So if our vendors are designed into these reference designs and they are going to high volume production, that is our goal here. So to empower the industry and to enable ease of design for all the companies out there is our goal here at APC. And that is how we plan to get to deployment in a couple of years. So does anybody have any other questions? It seems like Joe has a comment. Joe, did you want to come off mute and say something? Joe Dixon is from Woos International, and they are the largest PCB supplier in the world. Did I put you on the spot, Joe?
No, thank you. Thank you, Melissa. It's just a comment on the activity of the groups and what is working. Many of the collaborations that we're working on together have been motivated by hyperscalers requesting us to do the groundwork so that once this is completed, they could scale.
Thank you, Joe. Okay, so as I mentioned before, and as Jeff said, there's a lot of standards organizations out there, and our goal certainly is to leverage the work that they do, have them leverage the work that that we do to act in a synergistic way, to collaborate with the other standards organizations. We need to work in a more quick manner, and that means for us to stay connected and collaborate. And it's just a simple phone call away for us to collaborate with them and to create a formal liaison with them to disseminate information in a useful manner. And that's our plan.
I will make an additional comment that the OCI MSA has already published their specification. Rev 1.0 is available on their website. So there's no mystery about what they're doing. I suggest downloading and reading their specification. And so how it relates to what we do here, we will assess. But I think it indicates a particular direction for scale-up interconnects. And we'll, of course, be looking at how we relate to that. And Vikas already covered our activities at GlobalFoundries in relationship to OCI MSA spec.
I think that's it, unless anybody has a final comment. Anyone? Okay, great. Thank you again, everybody, and we'll talk to you real soon.